pyramids. So on our notes, if you printed these out, you have the same thing that I have in front of you, and you can look through the definitions. Here it says that the height of a pyramid is the distance from the top of the pyramid to the perpendicular base. So this distance right here, basically you need to look at that as though this is a right angle. The formula for that is this right here. 1/3 base area times the height. Sometimes you're given the base area, sometimes you're not. This is the same thing as 1/3 of a prism. So if you remember the volume of a prism, this is just 1/3 the volume of a prism. If we had a prism and a pyramid of the same height, the same base, we could actually imagine a solid, and you can look at some visuals online if you want, and you can fill that pyramid with water or some liquid and pour it into the solid prism, and 3 of those would fit in there. And usually during a regular class, I will show that visual. It just kind of helps students to see that. So right here, this is your base area, because our base is given to us here, but here's an example if the base wasn't given. So it doesn't really give you, let me rewrite that. I don't like the way that looks. For this one, they're giving you the base area, and this one is giving you the height. But sometimes the base area won't be given, you'll have to calculate it. So if it's not given, make sure that you go back and calculate that as length times width of that base. If it's a square or a rectangle, it could be a different shape. We could have a pentagonal based prism. It just depends. So let's look at these examples, and we should go through them very quickly because you already have the figure shown. Here is our base, and that base is given to you at the area that base is given as 30. So the formula is 1/3 base area times height. So for this one, it would be 1/3 times 30 times 8. Now, some of you are just writing answers. I need to see what it is, if you were using your calculator, what it is that you would put in your calculator, and this would be it. You don't even need a calculator for this, because 1/3 times 30 is 10. 10 times 8 is 80. The units, again, are cubic, so make sure that you have that 3 right here. Okay, this next one, the same process, 24 times 16 times 1/3. You can go ahead and do that. I'm not going to do all of these examples. Let's do this one. This one looks a little bit different, number 3. This one gives you the base here. It only gives you 5. For this one, if it only gives you one side, we're going to assume that it is a square. It should have given you this on here, marked all of these sides the same. If I give you a problem like this on the test, I'll mark all of the sides the same for you. Okay, and even putting right angles in here would show you that this is a square base. So the volume for this would be 1/3 5 times 5, and then our height, which is 5. And so our answer for this volume is 125 thirds. And so you can write it as 125 thirds meters cubed. And some of you aren't reading the directions, so make sure that you're giving me the answers in the form that it requests. If it doesn't request a form, if your problem has decimals in it, you can give it to me with the same number of decimals. If it doesn't have decimals, try and give me an exact answer, and then you can round it to the nearest tenth. So for this one, 125 divided by 3 is about 41.7 meters cubed. So it's 41 2/3 or an approximation would be 41.7 meters cubed. Okay, composite solids, we've talked about those. Those are a combination of any cubes, any cylinders, any pyramids. It's a combination of a number of solids. So here we have this two solids here. This is comprised of a prism right here and a pyramid right here. So we're going to calculate both of those. I'm going to call this A and this B when I show my work. So to find the composite of those, I know that the volume of A is equal to base area times height. And in this case, my base, you can see it's the same base as the one for the pyramid. And that base is 2 by 6. So 2 times 6, and then my height would be, if I turn it this way, this is how I'm looking at it. So I'm saying my base is 2 by 6, and the height of it is 4 centimeters. So that's how I looked at that. So 2 times 6 times 4. It really doesn't matter which way you write it. I like the base to be shaded so I can see what you're considering your base. And so my answer for that is 48. The units are centimeters cubed. Now the volume for the other part, the volume for B, the formula is 1/3 base area times height. And for this one, if we read through here, it tells me, or we look right here, sorry, it tells me my height is going to be 10. My base area is the same as what I got up here, so 1/3, 2 times 6 times 10. And this 3 we can cancel with the 6 and gives us 2 times 2 is 4 times 10 is 40. So our total volume for the whole thing, our total volume is equal to 48 plus 40, or 88 centimeters cubed. Okay, so show me the work, somehow identify it clearly so I can see that how you got each of those, so that way you can get credit. If I can't read it, if I can't follow your steps, I can't give you credit. Yeah, I don't know why this is stated as 8. This is wrong. It says 1/3 times 8. This is wrong. So we fixed it. Okay? All right. Moving on to the last two questions. Here it says, we're going to do each of these. It says the composite figure consists of what 3 parts? So I want you to look at that and see what parts are you seeing it comprised of. So we have a piece here, we have a piece in the middle, and we have a piece to the side. So I see 2 figures that look the same type of solid, and then one that looks different. And the 2 that look the same are pyramids, and the one that looks different is a prism. So if we were to calculate the volume of that, it appears that the 2 prisms are exactly the same in their volume, and then it appears that the prism, of course, is going to be different. But it does have the same base as the 2 pyramids. So it says calculate the volumes of the parts. So the volume for the prism is equal to base area times height. The volume of the pyramid, and I think I'll just abbreviate that with a V. But to differentiate between the 2, I'll write pyramid here, is 1/3 base area times height. And so I'm going to show the work on that, make this a little bit bigger so you can see my work. So noticing that the base here is already shaded for us. It is 1 by 8. So my volume here is equal to 1 times 8. and then the height of it here, or the height of it here is 1. So it's 1 by 8, and then the height of it's 1. So 1 by 8 by 1 for that prism. And so the volume for that is 8 meters cubed. Now the volume for the pyramids, there are 2 of them, but let's just do 1/3 base area. So it's 1 by 8. And then my height is 10. And so that's going to give me 80 thirds. Units are meters cubed, but there are 2 of them, so there's 2 pyramids. So that's going to be 2 times 80 thirds, or 160 thirds meters cubed, which is equal to 50 and 53, not 50, 53 and 1/3. So 53 and 1/3 meters cubed. Calculating the total would be just to add them together. So 8 plus 53 and 1/3 is going to give you 61 and 1/3 meters cubed. You may say that it's approximately 61.3 meters cubed. And that is it for the volume of pyramids. I want you to make sure that if you're doing a composite figure and you're doing more than one figure, that you show me part A and part B, or the different pieces, so that I can clearly see which one is which. And if it doesn't tell you what form to give it in, I want the exact answer. You can either write this as 61 and 1/3, or if you want to write the whole thing as an improper fraction, you can. 61 and 1/3 is more meaningful to me than writing it as the improper fraction. And then again, you can give it to me as a decimal after that. Okay, so that is it for these notes.